The first thing that I notice about number 30 is that it's a geometry question with a weird shape. And so that's a good sign that we need to kind of take this weird shape and turn it into something more useful that's more familiar to us. So this is a good example of our get back to basics strategy. Weird shapes on the SAT can almost always be divided back into normal shapes, which I would consider rectangles, circles, and triangles. And sure enough, if we just draw a straight line down from B, we're going to have a rectangle or square, it's hard to tell, and a triangle. So we're back to basics. So now we start looking at like, okay, what did they give us here? What can we use? Well, AD is parallel to BC. So that just means I'm going to have some more kind of right angles here. So here's another and another. So okay, it's starting to look more and more like a square. We still don't really know, but it's at least rectangular. We got that. We also have a right triangle based on what we drew. So okay, those are useful also in geometry. But then we have this other piece, CD is equal to 1/2 AB. But notice there's no numbers attached to that. I think it would be wise to put some numbers. You can solve this without that, but it's a great example of like, if you're getting stuck, give your brain more useful material to work with. Your brain is not good at working with algebra and variables and letters. It likes numbers. It can work with numbers. So give it some numbers and just see what it kind of churns out. So in this case, if AB were 4, then CD would be half of that. It would be 2. And because BC is parallel to AD, this extra little line that I drew in red is also going to be 2. They're the same because those two lines, BC and AD, are the same distance apart. So that's also 2. So now what we have here is a triangle where we know 2 of the sides. So we can do some Pythagorean theorem and find the third side. It's going to be messy though, right? So a squared plus b squared is equal to c squared. So we can do this side as the x side, right? From here to here. X squared plus 2 squared equals 4 squared. X squared plus 4 is equal to 16. Subtract 4. X squared is equal to 12. Now I think this is a case where most of you are going to reach for that calculator and be like, okay, what's the square root of 12? It's a messy number, okay? So x is equal to 3.464, blah, 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 blah. So, uh-oh, that's weird. Plus, at the end of the day, they're not asking for the side length. They're asking for an angle. How do I get from these lengths that I have to an angle? There must be something going on. Well, again, get back to basics. You don't have to know everything about geometry because luckily, the SAT tells us a lot of stuff. So I would flip back to the first page of the section and I'm going to see this reference chart. And there's a bunch of triangle stuff, right? It's all kind of like right here. And I'd be like, well, I know that I have sides and I want to get an angle. And if I look real close at these special right triangles, they're the only ones that include both sides and angles. So like the stupid answer here is it's probably one of these. And I would want to be like, okay, well, did one of them just like look like it? Well, it kind of looks like this 30-60, right? This 30-60-90 one. And so let's see, let's match up the ratios that they give us with the sides. So 2x, x, and x root 3. Well, this is definitely the 2x side. This is the x side. Probably shouldn't have used an x before. And this x side here, let's make it now the x root 3 is really what it is. And how do I know that? Well, I kind of just know that 2 and 4 are double each other. So that's, again, making a stupid assumption, putting some things there and seeing what works. And honestly, at this point, this is probably enough for me to then say, well, that means this is the 30-degree angle and this is the 60-degree angle, and that's enough. If I wanted to, I could double check my work and say, well, I did figure out that other side. X root 3 should be 2 root 3 according to this proportion. So 2 times the square root of 3 gives me the exact same number that I had before when I did the square root of 12, 3.464, blah, 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 same number. So that's proof that I've got it right now. I know what the angles are for this part of the triangle. We got to also be careful what they're asking for. They're asking for angle B. Angle B is not just this 60. It's this 60 plus the 90. So 60 plus 90 is 150, which is choice A, which is the answer. Some of you may have seen this really, really quickly, and that's great. If you have a geometry brain, this is not that hard. But if you don't, the point I want to stress is you shouldn't give up. The SAT is not asking about weird shapes. It's asking about familiar shapes in weird ways. So you just need to try to get back to basics, look for circles, triangles, and rectangles, and then flip back to those formulas if you get stuck again. But everything that they give you is going to be on the picture somewhere. And I think this is a good example where putting the numbers for C and D and A, B to actually get some values there did help me see something that I might have had trouble with otherwise, right? Because the formula for 30, 60, 90s involves a 2x and an x. The formula that they gave me does not involve a 2x, right? It involves a 1/2. So they twisted it. They flipped it around on us, making it harder to recognize. So there's a lot of things you can do. All of them are of the same kind of idea, which is make your life simple. Get back to basics, basic formulas, basic shapes, basic assumptions. That's all.